Okay, well, welcome once more to this session. We are still doing chapter 5. We're still doing chapter 5, which consists of ratio, regression, and differencing estimation. We've done with the ratio estimator. We've done with the regression estimation, sorry. Now, today we are going to finish off the chapter by doing the differencing estimation. So after doing that, so now we'll be sure that chapter 5 is complete. And again, I just want to remind you the scope of test number 2 is chapter 4 and chapter 5 only. Okay. So let's quickly go there. Let me just go to the window journal. Or before that, let me just do something here. So I can you wait a bit? Just want to go to the window journal. Okay. There we are. Let's start. We are doing, I think it's lecture 18, if I'm not mistaken. Lecture number 18, and it's about differencing. Like I said, we're done with the regression estimation. We're done with the ratio estimation. So now this is lecture number 18. And it's all about differencing or difference. Estimation. Okay. So the question is, how do you estimate the population mean, population total, the variance in difference estimation? So the population mean under differencing estimation is given by, or let me just say the difference estimator of population mean which is mu yd is given by mu yd estimate, isn't it? We're estimating the population mean under difference estimation, which is mu yd estimate is equivalent to y bar plus open brackets mu x minus x bar close bracket. Okay, so this is the formula that you can use if you want to estimate the population mean under difference estimation. So this can also be written as mu x, okay, plus y bar minus x bar, isn't it? We just change the position. You see, it's the same thing. So it's mu x equal to y bar minus x bar. Okay. And then this can also be written as mu x plus d bar. Okay. So this is the average. Y bar minus x bar is equal to d bar. Average of difference. Are we together? So therefore, all in all, mu yd estimate can also be equal to mu x plus d bar. So if you want to estimate the population mean under difference estimation, you can just use that formula. Are we together? So what about if you want to estimate the variance of that estimator? In other words, is the variance of the estimated population mean. How do you do that? Let me just say the estimated variance of the estimated population mean under difference estimation, which is mu yd estimate. So it's given by what? It's given by var estimate, open brackets, mu yd estimate. Okay. Which is equivalent to what? To n minus n over n. Okay. Then let's close the brackets, which is equivalent, multiply by summation of di minus d bar. Okay, square. All divided by n, open brackets, n minus 1. Okay. So this is the estimated variance of the estimated population mean under difference estimation. var estimate, open brackets, mu yd estimate, close brackets, which is equal to the population size minus the sample size, all divided by the population size, close brackets. Then we sum. We're summing from I equal to 1 up to n. Okay. Of di minus d bar. Okay, which is equal to that. Where in this case, let me just go down. Sorry. Where in this case, di, where di is equal to yi minus xi. Okay. And d bar is equal to what? Y bar minus x bar, as we have already indicated up there. Okay. So this is the one. Okay. So this one, y bar minus x bar is equal to what? D bar there. And then this di is equal to yi minus xi. I think it's clear. Now, we are done with the estimated population mean under difference estimation and the estimated variance of the estimated population mean under difference estimation. Now, let's go to the estimated population total under difference estimation. How do you introduce the formula in that regard. So let's say the difference estimator of a population total. You know that population total is tau y, but because now we're dealing with the difference, it's tau yd. Okay. So now the population total, sorry, here there is a total here. Okay. The difference estimator of a population total, which is given by that. So in other words, we're estimating the population total under difference estimation. So it's given by what? Tau yd estimate, because we're estimating it, which is equal to the population size multiplied by the estimated mean under difference estimation. Okay, that is the one. But you know that the estimated population mean under difference estimation is equal to what? This one. It's equal to, if you go up there, it's equal to what? To this one, isn't it? So you can substitute. Down here. So all in all, you're going to have what? Population size multiplied by mu x plus n d bar. Is it n d bar? No. Plus d bar, sorry. Plus d bar. Then close the brackets. So now we can multiply through by what? By the population size, which is capital letter N, isn't it? Then you get what? N mu x plus n d bar. Okay. But you know that n mu x is the same as what? If you still recall from the previous formulas, it's the same as tau x. So therefore, you can substitute n mu x, this one, by tau x. So you're going to have tau x plus n d bar. Okay, all in all, tau yd estimate, which is the estimated population total under difference estimation, is equal to tau x plus n d bar. So this is the formula that you can use to estimate the population total. Are we together? So let's proceed and find the estimated variance now. Estimated variance of that estimator. In other words, is the estimated variance of the estimated population total under difference estimation. So what we're saying is estimated variance of the estimated population total under difference estimation. So will be given by what? By var estimate of what? Tau yd estimate. So which is equivalent to what? To the var estimate of, you know that estimated tau yd is the same as what? N mu yd estimate, isn't it? Then close the brackets. And the estimated variance of that also equivalent to n squared, the estimated var of what? Mu estimate YD. And you know the estimated variance of the estimated population mean, we've already calculated it up there, which is what? Is this one? Where is it? Okay, I'm saying we have already calculated this one, isn't it? Up there. Estimated
Yes.
variance of estimated population mean is what? Can you substitute up there? Sorry. Okay, so now is the estimated var of tau yd estimate is equal to what? N squared. So the whole of this is equal to what? Can you give me that formula? Is n what? N minus n divided by n, isn't it?
Yeah.
Then summation
Of di minus d bar
d bar all squared.
all square. Yeah.
So you know that I is ranging from 1 up to n. Then it divided by what?
N
N
into n minus 1.
Yeah, into n minus 1. That's it. So, but let's check here. You know that this one can cancel this one, and we are left with n. Okay. So all in all, we are going to have n open brackets, n minus n close brackets, summation di d bar all squared. So ranging from 1 to n, then divided by n minus 1. Think that's it. So now this is the estimated variance of the estimated population total and difference estimation. Any question? None. Okay. So let's go to the example now. If there's no equation, let's go to the example. It's example 5 point. Just check it. 5.4, I think. Example 5.4 on page 47 on the lecture notes. Let me just write it down. Example 5.4, page 47, lecture notes. Can I? Do you have it?
Yeah.
Okay, it's fine. So now let me give you just 2 minutes just to try to analyze it. Talking about the auditors. In other words, they're saying the auditors are often interested in comparing the audited value of items with the book value Generally, the book values are known for every items in the population, and audit values are obtained for sample of these items. So the book values can then be used to obtain a good estimate of the total or average audit value for the population. Now, suppose a population contains 180 inventory items with a stated book value of $13320 American dollar. Now, let XT denote the book value, okay, and YI the audit value of the item. So a simple random sampling of n equal to 10 items yield the result shown in table 5.4. So we have got the table 5.4 there on page 48. We've got table 5.4. Okay, where consists of sample with a sample and audit values, which is yi, and we've got the book value, which is xi. Then we've got the di, that is the difference. Sorry, that is the difference. Now, just a simple audit value and book value and the difference. So it's 1 up to 10. Okay, so 1 up to 10, and the audit value started from 9, 14 up to 170. Okay. Then the book value started from 10, 12 up to 167. Okay. Then the difference, the difference, in other words, they take di is equal to what? Yi minus xi, isn't it? So 9 minus 10, you're going to get minus 1. 14 minus 12, you're going to get 2. And so on. The last one there, 170 minus 167, you get 3. That is the di. So that is the table given. Okay. So now, there are some given informations there that we are interested in. So let's start with the population size. What is the population size there?
180.
180. Thank you very much. Sample size?
10.
10. Then follow the tau x. I think tau x is there as well. Tau x is 1113320. Okay, let's quickly go to the question. The question says, let me check the question. Estimate the mean audit value Number A, estimate the mean audit value. In other words, they want you to find mu YD estimate, isn't it? That's number one. And they say estimate the variance of that estimator. Okay, let me say, let's find A estimated mu YD. B, we estimate the total audit value, which is tau YD. That's number B. Number C, we find the estimated variance of the estimated mean in part A, which is what? Estimate var of mu YD. Estimate. That's number C. Number D, you estimate the variance of the estimated total. So that is the var estimate of tau YD. So in other words, here for number C, you find the estimated variance of the estimated mean and a bound. Let's say and a bound. Let me do it like this. Find this one and a bound. Okay. Even here, number D, you find the estimated variance of the estimated population mean or population total and the bound. And the bound. Can we start now? Start with number A. We want to estimate the population mean of what? Of the audit value. Where do we start? Mu YD estimate. You have to find, there are many formulas out there that you can use. This is the one. But the question is, we don't have mu x there. We check. We don't have mu x, so you have to find mu x first. In other words, mu YD is equal to mu x, isn't it? Plus d bar. So you have to find mu x first. You can tell me what is the mu x now?
It is given by 13320 divided by 180.
Tell me the formula first so that you can see where is it coming from.
Or is the sum is given by tau x.
Okay, thank you. And the what?
Divided
Tau
by
x?
the population size.
Yes, thank you very much. That is the mu x. Now, tau x is what?
It's 13320.
13320. Then you divide by population size.
180. You'll get 74.
Okay, thank you very much. So, our mu x is 74. Okay, so now you have to find the what? the estimated population mean, which is what? Mu yd. Estimate mu x plus d bar. And mu x, we have already calculated it as 74 plus. So tell me the d bar now.
It's 0.4.
D bar, 0.4. Okay, yes, that's true, because it's what? Y bar minus x bar. And y bar, you have already calculated it to be what?
72.1.
72.1. And then x bar?
71.7.
71.7. So therefore, d bar is y bar minus x bar, which is 72.1 minus 71.7, which is 0.4. Thank you very much. And then 74 plus 0.4 is what? 74.4, isn't it? Do you follow? Is it clear for those other ones? Do you understand? Do you follow what we're doing?
Sir,
Yes.
we can also use the data from the table since we're given the DIs.
Okay.
Uh,
No, it's fine. It's fine. So it's
yeah.
fine. But anyway, everybody follow. Okay, now let's quickly go to what? The estimated variance of that estimator. In other words, we want to find this number B, né? The estimated variance. We just want to find the total first. Sorry. Let's find the total. Tau yd. Tau yd is equal to what?
It's n.
Yeah, it's n mu yd, isn't it? Like this. And this one we've already calculated it up there. And the population size, you know that is 180. Then you multiply by what? 74.4. Then give us the answer.
13392.
1339.
Yeah, 2.
2. Okay, that's it. So now let's find the estimated variance of the estimated population mean. That's number C. The estimated variance of the estimated population mean, and the formula, if you still recall, is what? N minus n over n multiplied by I is ranging from 1 up to 10 of di d bar squared. Then you divide by n into n minus 1. So what you have to do is to find the summation di d bar squared. So that means you come back here on that table. You're supposed to have another column here of di. Actually, you have a d bar. I don't know. Then di minus d bar. Then you square it. Then you find it going down. Can you do that? Then later here you have to sum them up down here. Here you're going to sum them up. Di d bar squared. So somebody can do that for us. So I'm giving you 5 minutes or so.
$56.4.
You're done.
Yes.
Oh, you're quick.
Yeah.
50?
6.4.
56.4.
56.4. That is the sum. Okay. The rest is simple. Let's go and substitute. So, okay. So now, population size is what? 180 minus 10 divided by 180. Then summation of that is 56.4. 10 times 9. Then can you find the answer for us?
Zero point 592.
0.552.
59.
Huh?
592.
0.592.
Oh, 59. Nine two, like this. Okay.
Yes.
Everybody got it right? Anyone got the different answer? Okay. Now, the bound is equal to 2 times the square root of the estimated var of the estimated mean, which is equivalent to 2. Estimated this one is 0.592.
1.539.
1.53.
9.
Okay. Huh?
1.539.
9.
Yeah.
So that's it. So that's very good. I want you to always round it to 3 decimal places, because normally when you round it to 2 decimal places, it's going to affect everything. So please, when you write, and I always indicate in the instruction when you are writing any assessment that you have to round your final answers to 3 decimal places. Please do that. And you mustn't round it like this. If you are having 1.5391731. I'm giving you the example, isn't it? So you can find that somebody just give me everything like this one. No, the instruction said round it to round out your final answer to 3 decimal places. Please just give me the final answer as 1.53539. Are we together? It's very important. That's we find that they just say 1.54. It's wrong. Round it to the 3 decimal places. Okay, you have to be careful about that. Let me just take it out. So now we are done with the bound. So now we have to calculate what? The estimated variance of the estimated population total. That's number C. D. Yeah, that's number D. So number D, the estimated variance or the estimated population total. Okay. And you know that is equal to what? N squared var of mu YD estimate, isn't it? So we are going to say 180 squared multiplied by 0.592. You see now, if up there, I'm just giving you the scenario. If up there you just say this one is 0.59 and you put 0.59 here, so it's going to affect the final answer here. So make sure that you round it to 3 decimal places so that it mustn't affect the final answer. So what is the answer then? I'm waiting for the answer.
Sir,
Yes.
for that one, the value is 19,180.8.
1980.80.
180.8.
180.8.
I said 19,180.8. 19,180.8. Yeah. So, sir, I'm having a question here because I think it's best if for the bound we don't round it off, we substitute the value as a whole because it's affecting the final answer. If I use that other one, I'm finding 19,176, which is the correct value. So this one, since we rounded off, it's affect. So this one is wrong. The correct value
you know
is
what
19.
is happening? Oh, yes, I understand your story. Now,
yes.
okay, let me just answer you in this way. So here you find that you are bound. Okay, let me show you. Here you find you are bound to be 5.3. Let's say I'm just giving you the scenario. Okay, but when you write it here is to round it off to 3 decimal places, isn't it? So, but anyway, when you continue, I think you can use the whole of it. If it's affecting, you use the whole of it, and then you do what? And use it here, and find the final thing. Is what we are saying.
Is what I'm saying, sir,
Yeah.
because that one is incorrect. The correct value is 19,176. So we have to substitute
Yeah,
the whole
that's true.
value. Eh.
Yeah, that's true. Take the whole value and substitute here. Here, I just want the final answer, because here for the bound, if you write everything like this one, it's not fair. It's not good at all. I said round your final answer. Here for bound, the final answer is this one, isn't it? But when you want to use this value, you know that it's not this one, it's more than this one. So you use this one and use it here. And here, when you write the final value, you have to round it off to 3 decimal places. Okay, this is what I want. But if this one is too big and you want to use it down there, so you're going to use it as it is, so that you can get the final answer correct. I think that's it.
So, what's the point of rounding maybe on C, whereas on D, when we use that answer, we don't have to round it?
The instruction said round off your final answer on that particular question. You round out your final answer to 3 decimal places. So you just want to write it as like this one, to have a lot of digits there.
But it's better
Sir,
that way to avoid confusion.
Sir,
Yes, I'm listening.
sir, I think the better way is to use that one, the simplified one you give us, that you are going to use n into n minus n, divide by the small n, then multiply by the standard deviation of the DI.
You mean this one?
Yes, I agree. This last part is the standard deviation of the DI, like if you divide by the small n. So I agree this one, when simplified, it will be n into n minus small n, all divided by small n, then multiply by the standard deviation of the, I mean the variance. Yeah, is the variance
What are you
of
talking
DI.
about?
I'm talking about the same formula. I agree that last part is say.
You're including the standard deviation, and I'm confused. I can't see the standard deviation here.
Sorry, sir. It's just a mistake. I'm saying the last part, which is the summation from I equals to 1 to 10, di minus
D bar.
d bar all squared divided by n minus 1 is the variance of the di. Is the variance of the di. Yes, the sample variance for the difference.
So, but there will be somebody who would want to use this value here. Yeah.
Then they'll have to take it as a whole, not round off.
Yeah, this is what I'm saying. That, but when you write the final answer, I want to see the 3 decimal places. But when you use it, because it might affect the final answer, take it as a whole. Isn't that you know how many digits are there? So you take it and use it there. But when you write the final answer here, I want it to be in 3 decimal places. But anyway, I'll see it. If it's in 3 decimal places, I will see that now this one is different with some few digits. If, like what you said is what? The answer here, if you use this one?
It's 19,176, the correct answer.
176.
Yes.
Point what?
Only.
It's like this. Oh, and this one is 19,180.800. That's what you're saying. So yeah, these ones now, they're two different. So I think you have to use the whole of it. It's what we know. You use the whole of it. When you write the final answer, I need to be in 3 decimal places. That's it. let's not debate about that. I'll see whether your answer is too different from mine, and whether you applied the correct thing. I can be able to see that one. The only problem is when you round it off to 2 decimal places. That one is going to affect the whole answers. So please write it to be in 3 decimal places instead of 2. So I think this is what I wanted to introduce today, and I wanted to give you the what you call the feedback. So let me just give you this time to go and maybe prepare for the test. At 1 o'clock, we have to meet and then talk about the feedback. If you have some questions, we will be trying to clarify or to answer that. Is that fine?
Yeah. So
Hmm?
can you scroll back to question B? I want to check something.
Yeah.
Yeah, I got kicked out, so I just want to copy this.
Oh, okay, it's fine. It's fine. But do we agree that you can meet at 1 o'clock so that I can give you the feedback, even though you got your scripts, but just to show you how you were supposed to answer the questions. And then if you have any questions, you will be given an opportunity to ask those questions at that time. Is it fine?
Yeah, it's fine, sir.
Okay. No, it's fine. We are going to meet at 1. So for those who are still writing, please, I'm giving you the time to just copy or to ask questions.
Sir,
Yes.
I want to clarity on how do you differentiate between the UX and TX? Because
How do we differentiate what?
between the TX and UX.
Or TX and UX?
Yeah.
They will actually normally, unlike here in this example, it was not clearly stated. But normally they will talk about the total of something. And mu X, they will talk about the average of something. Okay, like what we did previously when we were talking about the
Okay.
oranges. Yeah.
Yeah,
Yeah.
the
So
oranges, it was about the total.
yeah. So it's something like that. So I think it's going to be clear. So immediately when you see the average, and then that other one is the total of something based on the variable x. So you will see that they are referring to that.
Okay, sir.
Okay. But we are ready, guys.
Yes,
Are
Hey,
you
so
ready for?
these formulas are confusing. They are like not the same.
Just provide us the formula sheet. I swear it.
But I can't give you the formulas now. Do you understand that? Because there is somebody who said, please give us the formula so that you can see which ones are coming. No, that one is not good. He said, we can't do that. You're going to see them there. So that is why we normally say that, okay, make sure that you know these formulas, even though you know that we are going to give you some of them, but please know them. Okay? So we're going to give you those formulas.
So can you
But
please
some of
scroll
them you
up
have to know
from
them, isn't it? It's not all of them that we're going to give you.
Even the ones for regression are going to give us.
Hey, even the one for regression. But you can find that some of them are just like the issue of, I'm just giving you another scenario. To find a bound, you know that is the bound of anything. If you are talking about the bound of the estimated mean, the bound of the estimated mean, yes, you know that is b equals to 2 times the square root of the var of mu yd hat. You know this. So there's no need for me to give you this formula. You know it. So there are those formulas that there is no need to give you there, but there are formulas that you can manipulate out of the formulas that are given. Because these formulas I
So,
know there
sir,
are many. So even in my case, I can't give you all of them. So it will be like the whole question now is full of formulas instead of the questions. Yes. Yes.
can you please show us that number one of your quiz?
Come again.
That number one your quiz. Can you please show us the formula?
Number one of quiz, I can't even remember.
Hey,
So, but
sir,
anyway, no, I understand what we are talking about, but we are going to talk about it in the at 1 o'clock, isn't it?
okay, sir.
I'll show you how to. If you want the answers from that, I'll give you the answers at 1. So, but we managed to finish a quiz.
Sir,
Yeah.
Some
Yes.
of
can
us
you
here.
please scroll up?
Up.
I want the
You managed.
questions. Yeah, the
Okay.
questions.
These are the questions. A to D.
Yeah, fine.
Okay. I was asking, did you manage to finish the quiz? Quiz number 2.
No,
Sir, myself, sir, I'm talking
No,
on
sir.
behalf of myself. Myself, I
What was the
didn't
problem?
finish it, sir. When are we rating the special for those who missed it?
Immediately when you finish writing test number 2, I'm going to give you. Actually, I don't know. We can agree with the class rep. I can give you quiz number 3, like what we did in the first semester. Remember, we gave you 3 quizzes, then we took the best 2. So that means I'm going to give you another quiz for those who missed quiz number 2. So obviously they're going to write quiz number 3 as well. But I'm going to take the best 2. Is
Thank
it
you,
fair?
sir.
Is it fair?
It's
So
fair.
each and everyone is given an opportunity. You can be, if you want to write, you can write. But if you don't want to write, it's fine. At the end of the day, I'm going to get to take 2, the best 2. That's it. So for the test, you know that we won't have another time for writing another test. So make sure that you do well. Then later,
How many marks, sir,
for
for the test?
marks, I think
It's
they are
out of
50
how
or so.
out of
I
50.
think they are 50 or so.
Okay.
I think it's out of 50. So I can't remember because I've already submitted the question paper. But it's not difficult. So, but it needs somebody who have studied, because if you have studied, you don't need even those formulas. Because remember, it's not for the first time to give you formulas. We have been giving students formulas for the past 5 years or so. So this time around, you guys, you are just coming with some issues. I don't know.